A woman in New York opens her laptop and video calls her mother in Mumbai. The picture is sharp. The voice has no lag. It just works like magic pulled out of thin air. But her words did not float up to a satellite in space. They dove into the ocean. They raced along a glass thread no thicker than a garden hose, lying in total darkness on the sea floor, next to old shipwrecks and cruising sharks, for 8,000 miles, and then climbed back out on the far side of the planet. All of that happened in the time it took her to say hello. That call lives at the bottom of the ocean, and almost nobody knows it. We all assume the internet is wireless, or somewhere up in the clouds, or in space. That assumption is wrong in a way that matters. Roughly 95 to 99% of all data that crosses between continents travels through physical cables lying on the ocean floor. Satellites carry only a tiny sliver, and these cables break constantly. On average, one gets cut somewhere in the world every 2 or 3 days, which adds up to around 200 breaks a year. When one snaps, a whole country can lose banking, video calls, and half its internet in an instant. So the entire global internet, the thing you use every single hour, hangs on a few hundred fragile threads that a single dropped anchor can cut. Here is the one idea the whole video hangs on. The internet is not a cloud. It is a plumbing system. Think of the continents as houses, and the oceans as the ground between them. To get water from one house to another, you do not spray it through the air. You bury a pipe. The internet does the same thing. To move data from one continent to another, engineers lay a pipe on the sea floor, and instead of water, it carries pulses of light. There are around 570 of these pipes wrapping the planet right now, and some stretch more than 20,000 kilometers, which is halfway around the Earth. So how does a beam of light cross an entire ocean and stay alive the whole way? Let me walk you through it, step by step. It starts with glass, not copper. Inside the cable sits a bundle of fiber optic strands, each one about as thin as a human hair. Data is turned into flashes of laser light, and those flashes shoot down the glass, bouncing along the inside of the strand. Light is the fastest thing in the universe, so this is how your message crosses an ocean in a fraction of a second. A tiny flicker of laser is doing all the work. The glass is wrapped in armor. Near the shore, where anchors and fishing nets are a real threat, the cable is coated in steel wire and tar and can be as thick as a soda can. Out in the deep ocean, where nothing bothers it, the cable slims down to the width of a garden hose. Less danger, less armor. And it goes deep. In some places these cables rest more than 2 miles beneath the surface, deeper than most mountains are tall, in crushing cold and total black. Light gets tired, so the cable feeds it. Over thousands of kilometers, the light signal fades and weakens. So every 60 to 100 kilometers, the cable holds a device called a repeater. A repeater grabs the fading light, boosts it back to full strength, and shoves it onward. A single transocean cable can hold over 100 of these boosters, all powered by electricity fed down the cable itself, through the same line that carries the light. A special ship lays the whole thing. This is the part that stunts people. There are only about 60 cable-laying ships on the entire planet. One sails slowly across the ocean, sometimes for weeks at a time, gently paying out cable off the back like a spider spinning a web. In shallow water near the coast, a machine on the seafloor plows a trench and buries the cable so anchors and trawlers cannot reach it. One wrong move, and the whole line snaps. When it breaks, a human fixes it by hand. Cables get cut all the time, and around 86% of the damage comes from ship anchors and fishing gear near the coast. When one breaks, a repair ship races out, drops a grappling hook 2 miles down to the pitch-black sea floor, snags the broken cable, and hauls it up to the surface. Crew members then splice the glass fibers back together by hand on the deck, align them under a microscope, and lower the whole thing back down. One repair can take days, and there are only so many ships to go around. Traffic reroutes, if it can. This is why the internet does not fully die when one cable snaps. The system is a web, not a single line. When one cable goes down, your data tries to take a different cable the long way around, and you might just notice things feel slower. But if a region only has 1 or 2 cables and both go down, that place goes dark until a ship arrives, which can take days or even weeks. Let me make this real with a number and a story. In 2008, several cables in the Mediterranean Sea were damaged around the same time, and internet across Egypt, India, and the Middle East slowed to a crawl. India lost around 60% of its internet capacity in a single afternoon. Millions of people, call centers, banks, and businesses were all crippled because a handful of glass threads on the seafloor got nicked near Egypt. Now stretch your imagination the other way. A single modern cable can carry hundreds of terabits per second. That is enough to stream tens of millions of high-definition movies at the exact same moment, all through one hose lying next to a shipwreck. That is the scale we are trusting to a single rope on the ocean floor, guarded by nothing but water and luck. And here is a fun gut punch. Sharks have actually been filmed biting these cables, probably drawn in by the faint electric fields around them. So yes, at least a few of your emails have technically survived a shark attack. The internet is not in the sky. It is a set of around 570 fragile glass pipes lying on the ocean floor, and nearly all data between continents crawls through them. Cut 1, and a country can go dark. The most modern thing in your life runs on the most fragile wire on Earth. Subscribe to Tech with Joel for the hidden physical machines behind the tech you use every hour, explained fast. Now tell me in the comments, did you honestly think your video calls were bouncing off a satellite this whole time? Next time we go deeper and follow one single click all the way from your finger to a server on the other side of the planet, every stop along the way. Subscribe to Tech with Joel.